Right, hello. This time I'm going to go through the reactions of acyl chlorides with things like water and amines and all that kind of stuff that we discussed last time out. Um, the name of this mechanism is the nucleophilic addition-elimination reaction, if you need to ever name it. And let's just crack right on and have a look at this. So just very quickly, where does it fit in the specification? So this is the AQA specification, and we can see that we need to know the structures of all these things that we're going to do. I'm conscious I haven't discussed acid anhydrides yet, but I shall be doing that next. We looked at reactions before in terms of the reaction with water, alcohols, ammonia, and primary amines. I have not yet discussed the use of anhydride in making aspirin, which we'll bring into the next one, which is also required practical. And we will be looking at today this section here on the mechanism. So as the name implies, nucleophilic addition-elimination, we're going to have a nucleophile involved. We're going to have an addition step, and we're going to have an elimination step. So expect a few curly arrows in this one. So let's start off with a structure of an acid chloride. Okay, so I've just done ethanol chloride here just because it's an easy one to do. And I need a nucleophile. So nucleophile we would typically draw like that, just showing a lone pair of electrons, which is what makes it a nucleophile. In this case, I'm just going to show an additional hydrogen attached to it because in all the cases that we look at in this particular topic, the nucleophiles all will have a hydrogen which they will lose at some point. So let's crack straight on with some good old curly arrows. Right, I'm going to just put some partial charges on, just to help us think about what's going on. You do not need to put partial charges on in an exam unless you are asked to. So because my carbon now is attached to two electronegative or relatively strongly electronegative atoms, both of which would be delta negative, so my carbon here is getting pretty delta positive. Okay, a lot of its electrons are drawn away from it by these other atoms that are attached. Consequently, this is why it's so prone and susceptible to nucleophilic attack. So let's look what's going to happen. So we've got our partial charge up here, so we know this carbon is delta positive. So our electrons are going to come from our nucleophile down here, and they're going to form a bond with that carbon. So if they form a bond with that carbon, this carbon has too many bonds, it needs to lose some. So the first way it's going to lose some electrons are the electrons from that bond are going to go up to the oxygen. So moving on. Okay, so here we are partially completed intermediate. So our electrons have come from that bond up to the oxygen. So this oxygen now has got a lone pair of electrons. And because it's taken both electrons with it, it's going to have a negative charge. Down here, our nucleophile, this has now formed a bond with the carbon, so it has effectively lost an electron into that bond. So our nucleophile now has a positive charge. So we've got negative charge at the top, positive charge at the bottom. So overall, there is no charge. Okay, just like before, there was overall no charge over here in our reactants. So in this intermediate, there's no overall charge. So this stage here is the addition step. So this would be the addition step. Because I'm adding my nucleophile. Apologies about that. So I've added my nucleophile to the ethanol chloride in this case. So now we've got this intermediate. Now we're going to do some elimination. So the first part of this is we're going to reform our double bond there. Meanwhile, we're going to kick out our chlorine. Okay, so remember, these all happen sort of simultaneously. And what we're going to form over here, we've reformed our carbonyl. We've got our nucleophile. It's still got a positive charge. And we have also formed Cl-. So the story's not quite over yet, so I'll just redraw this here. This is like sort of step 2 of this. Now, we want to lose this positive charge on our nucleophile here. So the manner in which this happens is that the electrons from that bond return to the nucleophile. Now, you will sometimes see this as the Cl- taking it off, so we would get a bond forming with that hydrogen there to make HCl, which would be the case in a nucleophile such as water. But in your exam, you don't need to show that step there. So that when we do it with amines, there is a potential for messing it up and missing and losing a mark for it, showing it being removed by the chloride. So I would be tempted not to bother with that one, because in your exam mark scheme, you get the marks up to this point here. Anyway, we've now got a product. So we've now formed our carbonyl with what was the nucleophile attached, and in this case, we've released HCl. So let's look at some specific examples of this. So we're going to start off looking at ethanol chloride and water. So I've drawn my structure of ethanol chloride here, and I've sort of blown out white water a little bit here. I've shown one lone pair. Obviously water has 2 lone pairs, but I'm only showing one for the purpose of this mechanism. So first curly arrow, going from my water to my delta positive carbonyl carbon there. As that moves in, it's going to push the electrons away from it, and those electrons are going to move up to the oxygen there. So this is my first addition step. So I have shown my lone pair on the oxygen now and a negative charge. My water down here still has its 2 hydrogens attached, but now we can see we've got 3 bonds formed from this oxygen. So this means the oxygen has a positive charge. So next step. This is our elimination step. So our carbonyl is reformed as our chloride is kicked out. So notice my curly arrows come from the bond to the atom, and it's gone from the lone pair to the bond between them. Don't show it going to the carbon, because it's forming a bond in that case. In this case, don't show an arrow coming from carbon or anything like that. It's going from the bond to the chlorine. Mr. C there, no one noticed. Okay, so now I've reformed my carbonyl. I've got an oxygen attached to it with 2 hydrogens and a positive charge. So my last step here is to kick out my hydrogen . And I've formed my acid, and I would also have, in this case, HCl. So like I mentioned before, you could have shown, let's do it in green, eliminated chloride there, removing the hydrogen. But as I will discuss later on, there is a pitfall there. Okay, moving on. So this is ethanol chloride and methanol. So I've drawn my ethanol chloride here. I haven't shown any partial charges. You can do if you wish. And here I've drawn out my methanol focusing on the oxygen. So I've shown the methyl group attached to the oxygen and the hydrogen all blown out with the bond shown. So got my lone pair here on my oxygen. My electrons are going to move from the lone pair and be attracted to that carbonyl carbon up there. As that moves in, the electrons here are repelled a little bit, so they're going to move up to the oxygen. I then make my first intermediate. Okay, so I've missed something on this, so hopefully you've spotted that I should have shown a positive charge there. And now let's crack back on with our mechanism. So now we're going to eliminate, so we're going to remove something from this molecule, and the victim is the chlorine. Okay, so now we reformed our carbonyl from here. We've got rid of the chlorine, so that's hanging around over there somewhere. And now I've got my oxygen attached to my CH3, attached to my hydrogen. So I'm going to show my positive charge again on my oxygen. And we need to get rid of that hydrogen there to make that oxygen happy. So then we've made our product down here. We've made our byproduct, our HCl. Remember, it's a vigorous reaction. We're going to see some steamy fumes of HCl being produced. And now I've made 2 carbons there. It's an ester, C double bond O, O, with a methyl group there. So it's an ethanoate, ethanoate. And because I've got a methyl group there, I put that there, so I've now made methyl ethanoate. Alright, next up is production of an amide. So we're going to react our ethanol chloride with ammonia. Same gig as before, I've got my carbonyl. If I wanted to, I could have shown some delta positives, delta negatives. I will this time, just for fun. Just to help us think about why this reaction is happening. And my lone pair on my nitrogen here is going to be attracted to this carbon over here. As this moves in, it's going to push these electrons over to the oxygen there. I'm showing it from the bond to the atom. This time I'm down on the ammonia. I'm showing it from the lone pair to the carbonyl. First step. So in this middle step here, I've got something to populate this with. So I need my lone pair on my oxygen, and it's got a negative charge. Down here, my nitrogen, you can see I've just blown out 1 hydrogen. You can imagine what I'm going to do with that afterwards. And now I need to whack in some curly arrows to show the next step. So this time, I'll show it this way. So we'll talk about, so this chlorine is going to be kicked out. Okay, that's going to remove, because chlorides are a good leaving group. It likes having its electrons. And my oxygen is going to donate that lone pair into that bond between the carbon and the oxygen to reform the carbonyl. So over here, I'm almost there now. So I've released a Cl minus. It's floating around somewhere. Now, what I'll show here is what happens when we have an excess of ammonia in here. So this is why I said previously not to worry too much about how this hydrogen is removed. So what happens is we've got some more ammonia left hanging around. This is going to take the proton. So get my blue pen for my curly arrow. So my electrons here, that returns to the nitrogen, as I've shown with the ones previously where it's returning to the oxygen. But this time I can show this here. So now what I've made my final amide product, my ethanamide, NH2, no charges on this section. So now this NH3 has become NH4 plus. This then would buddy up with the Cl minus. So what I've produced here is ammonium chloride. So the HCl isn't produced, okay? It's almost like it's been neutralized with the ammonia to make ammonium chloride before it's seen the light of day. Okay, so we're not going to necessarily see our steamy fumes of HCl in this case. This is a fair mechanism for this one. If you showed this being removed by the chloride, you would remove a mark. You would lose a mark for that, which is why I suggested earlier on you don't always have to show this step. And if I remember by the end of this video, I will show you a couple of mark schemes on that basis, if I can find them. Right, so this leaves just one more to do, and that is the reaction between ethanol chloride and a primary amine. Okay, in this case I'm going to use methylamine, and I've drawn them out. This time I haven't blown my hydrogen out. I thought I would draw it this way just to give a bit of variation in all this. I'll not do partial charges because I'm hoping we all know where they're going to be now. So think about exactly what you're doing. Almost talk yourself through this in your head as you come through. So what's happening, what's moving where? So my lone pair electrons here are going to be attracted to this carbonyl carbon. So that's where I'm drawing my arrow, from the lone pair to the carbon. Simultaneously, those electrons are going to be pushed towards that oxygen. So they're going to go from the bond, where they currently are, to the oxygen. Moving into the next step. Got my oxygen, it's now picked up a lone pair because those electrons, those two electrons in that bond over there, are now over here. That's where the electrons are, formerly known as a double bond. Now it isn't. I've got my chlorine there. Now my nitrogen, it's attached to two hydrogens. This time I'm going to blow it out so I don't forget it later. And a CH3. Stick on a positive charge. I've got a negative here, I need a positive here because there's no overall charge on this left side, so there's got to be no overall charge in this middle section here. Right, what's going on now? Well, I've got my chloride, I'm going to remove that one. I've got my oxygen here, which is a negative charge, so there. So from the lone pair to reform a double bond, from the carbon-chlorine bond to the chlorine atom, going to form a chloride ion. Next step here. So I've now reformed my carbonyl, so I'm showing this as a trigonal planar type structure now rather than randomly flat thing. Got my nitrogen, right, my blown out hydrogen there, and then HCH3. So nitrogen, oh, I need my red pen. I've got a positive charge. My chloride is buzzing around over here somewhere. We'll worry about that later. I've got some more methylamine lurking around. There it is. This is going to help facilitate this removal of a proton here. So the electrons from my NH bond go to the nitrogen to get rid of that positive charge there. Now what I've formed, I've got my product. So look, this nitrogen's bonded to a hydrogen, to a methyl, and then the carbonyl carbon. It's got 3 bonds, it's standard kind of stuff. My byproducts here, I've got my NH, so here it's NH2, so now this is NH3, CH3. This whole thing is going to have a positive charge. This then we can team up in an ionic bond with the chlorine, or chloride rather. So let's name these things. So this thing has got 1, 2, so it's ethana, okay? Ethanamide, because I've got this N connected to the carbonyl carbon. So it's ethanamide. Hopefully you can read my writing on this one. I know I realise that my camera's not 100% focused. It's a bit of a wonky angle. And anyway, what I've got is my methyl group. And hopefully you can remember from last time, How do we say that the methyl group is attached to the nitrogen? Well, I say it's N-methyl ethanamide. Right, now this thing down here, this ionic compound, our salt that we produced as a byproduct, methyl, ammonium, I'm really going to run out of page here, ammonium chloride. So when amines become a positively charged salt, so they picked up protons, we call them ammonium ions. Okay, so the methyl bit just tells you how many organic-y bits there are stuck on it. If there was none, if it was just ammonia that gains a proton, it's ammonium chloride. But this time, because it was an amine, methyl ammonium chloride. Right, now I promised a look at a mark scheme of things. So here's a question. I think this is from the 2017 paper. Yeah, I'll put it up there. It's 2017. So I thought, yeah, instead of just looking at marks, let's do it. Okay, so an amide link is also formed. So this is following on from the previous bit of question. When an acyl chloride reacts with a primary amine, outline and name a mechanism for this one and this amine here. Give the IUPAC name of the organic product. Well, chance of me remembering to do all that at the end is probably slim, but let's have a look. Okay, so let's have a go at this. So, reaction between CH3, CH2. Now, this is the crunch bit of the molecule. So that's my acid chloride there. Now my amine, NH2, CH2, CH3. So what am I going to do? I'm going to do my mechanism. Name and outline a mechanism. So it's a nucleophilic addition-elimination. Remember to get that in tick, done. Lone pair electrons attracted to the carbonyl carbon. The electrons of the carbonyl go to the oxygen. Okay, first step done. So CH3, CH2, O, Cl, N, H2, CH2, CH3. Okay, so now we need to populate all the bits to get our marks for our structure. So I'm going to put some lone pairs on there. I'm going to put a negative charge on there because it's now picked up those. And down here, this nitrogen, because it's formed a new bond here, this is essentially lost electrons, so it has become positively charged. Can't believe this has been 23 minutes and 40 seconds already. Right. Okay, so what happens next? Well, we're going to kick out the chlorine, so that kicks out there. I'm going to put these two arrows on there. So now, I was using blue pen, wasn't I? We'll stick with that. So CH3, CH2, C, back to being a carbonyl again now. So I've got my nitrogen. I'm going to blow my hydrogen out this time. H, CH2, CH3. So remember, we've got our chloride floating around, but we're not going to worry about the chloride now. I'll come back to that later. What I'm going to show is this stuff here, helping remove the hydrogen. Sorry, I should use green arrows, shouldn't I? Never mind. And I also forgot my positive charge on here. Okay, so the electron's going from the NH bond up to the nitrogen, and then the hydrogen is being removed by this stuff. So our product that we're going to have down here, I'll draw the whole thing out, CH3, CH2, CO, NH, CH2, CH3. Okay, so let's break our naming down in chunks. So it's an amide. Okay, so this bit here is an amide. It's got 1, 2, 3 carbons in it. So it's going to be propanamide. And what's attached to it? Well, I've got an ethyl group on my amide. So N-ethyl, I can't spell any longer, ethyl propanamide. Okay, I should have drawn that a little bit closer to it, but I think you get the idea. N-ethyl propanamide. Right, let's have a look at our mark scheme. So here we go. I might need to just zoom in a little bit so you can see a bit better. There we go. So let's look at this. So this is the first step. So here we've got the ethylamine with the nitrogen and a lone pair going to there. The curly arrow coming from the bond to the oxygen. Then we've got our intermediate structure. These have shown this as a simultaneous step. You can show this in 2 steps like I do. It's not a problem. Now, this final step, so this top step here, oxygen reforming, the carbonyl and the chloride being kicked off, that's all happy days. Now, it's shown in brackets here, the RNH2. So this is from the ethylamine, removing the hydrogen. Now, if you look over on this side here, so where we've got our marks from, okay, so one for naming nucleophilic addition-elimination. Mark 2 is for the lone pair on the nitrogen to the carbon here, so we said M2 there. Mark 3 is for the carbonyl, so we're racking the marks up quite quickly on this one. Then from the down here, where are we? Mark 4 here for the structure of the ion, so the intermediate that we've got, including 2 charges. Then the 5th mark is for the arrows from this step of the mechanism. So arrow from the lone pair, from the bond to the chlorine, and from the hydrogen to the nitrogen. So it says may be scored in 2 steps. So that's the way I normally break it down. It says ignore the use of the amine to remove it, but, this is the put, penalise the use of the chloride removing it. So do watch out for this, okay? Because you don't need to show this to remove it, but they will penalise it if you use the wrong thing, then I'd almost be tempted to leave it out, okay? And ethyl propanamide was the last mark of this. So 6 marks for this mechanism, including the name of the mechanism and the name of the product. So hopefully this has been okay for you, and I will see you again sometime soon, probably. Bye.